Okay, back to number 17. Number 17 says let G be this function. What is x coordinate of the point of inflection? So point of inflection is where G double prime changes sign. So I got to find G double prime. So first, G prime of x, if you take the derivative of an integral, this is where this x just replaces t. So I get x squared minus 5x. So G double prime of x will equal 2x minus 5. This is a line. It crosses the x-axis one time. That's at 5/2. So get B. Okay, another very hard problem. You are welcome to take the derivative or find the formula for the derivative of secant. I didn't do that, so I'm going to think of this as 1 over cosine of 2x. Or cosine of 2x to the negative 1. Now, there are no cosines in the answers, so I'll think of it back as secant once I'm done. So this is a product rule. And this is a super tricky problem. So do the derivative of the first times the second, which is secant of 2x, plus the first, which is x cubed, times the derivative of this, which I would handle the negative 1 first. So I get negative 1 times cosine of 2x to the negative 2. Handle the negative 1, got to handle the cosine, which is negative sign, so that negative goes away. So I get sine of 2x times 2. So I got this guy here, which is fine. I'm just going to leave him alone. I got to work on this guy. So I got a 2 and a 1 and an x cubed. So I got 2x cubed. I got this sine of 2x. And I got over cosine of 2x squared. So I'll think of that as cosine of 2x times cosine of 2x. And this, one of these over the other one is a tangent. So I get tangent. So I get 2x cubed tangent of 2x. And then this remaining cosine on the bottom is a secant of 2x. So I've got this plus that part, which is how I get D. Pretty hard problem. It says particle moves along the y-axis, this equation here, and it says which of the following describes the motion of the particle at time t equals 1. It's talking about where it's moving and whether its velocity is increasing or decreasing. So I need the velocity. So velocity would be 3t squared minus 8t plus 4. And I want to know the velocity at time 1. So at time 1, I get 3 minus 8 plus 1, which is negative 1. So if velocity is negative, we're moving down the y-axis. So if we can eliminate C and D. Got a 50-50 chance now. And then it wants to know whether that velocity is increasing or decreasing. That would take the second derivative, the acceleration, which would be 6t minus 8. If I plug a 1 into there, I get negative 2. So I'm moving down, but I'm moving so down with decreasing velocity. Number 20 says the area under f of x from 1 to 4 is 8. The area under g of x from 1 to 4 is negative 2. And it says which of these cannot be determined. We can definitely flip this around and get a 2. We can definitely multiply this by 3 and get a 24. And we can definitely do a combination of that here. There's no way to know what happens when I multiply my equations together. So therefore my answer is C. All right, so this is a limit definition of a derivative. So if we go back to the very basic idea, this is just a very fancy way of saying f prime of x, which means this right here. We're just taking the derivative of this guy right here. So here is a limit definition of derivative. We need to take the derivative of this guy right here, which is 2 cosine of 2x. So that's D. 22. Okay, so slope fields. Hopefully you've been working on those this past week. The first thing I notice about this slope field is it is consistent along horizontal lines. That means only the y matters, which means this equation does not have an x in it. So I can eliminate A, I can eliminate B. The next thing I notice is every place I look has positive slopes, eliminating C, and I'm down to D by process of elimination. 23 says the base of a solid is bounded by the y-axis, the x-axis, the graph e to the x, and the line x equals 1. Says perpendicular to the x-axis we have squares, so I'm going to draw a square quick, give it a little depth. And the base here, that base is that base, so the square is sticking out towards me. So I need to figure out the volume of this, which would be b squared, and this would be a dx. So I got to find the base. The base is e to the x, so I get volume equals e to the x squared dx, which is e to the 2x dx. I got to integrate that. Don't know why I wrote that so far away. So I got e to the 2x, and we're going from 0 to 1. The antiderivative of e to the 2x would be 1/2 e to the 2x. From 0 to 1, I plug a 1 in, I get 1/2 e squared. Plug a 0 in, and I get 1/2 times e to the 0, which is 1, so just 1/2. And I end up getting b. Last one here, fundamental theorem of calculus. What's this equal to? Well, fundamental theorem says that the integral from 0 to 12 of f prime of x is equal to f of 12 minus f of 0. F of 12 is -4. F of 0 is 4. And -4 minus 4 is -8, which is how I get A. Thanks, guys.